Hey guys, welcome to the NC Barndo Build channel. If you're a returning subscriber, thanks for watching another episode. I really appreciate it. Your guys' love and support for the channel really means a lot to me. If you're new here, welcome. My name is Brian, and I am documenting the process as my wife and I attempt to build our own post frame home. We are not licensed contractors. We're not professional builders. We're just DIY individuals trying to save a ton of money and build our own home. Now, since I am not a professional builder and I'm not in the HVAC industry, I wanted to get a professional's take on our build and talk to someone about what they would recommend if this was a build they were doing. So what I have for you today is the highlights of a 1-hour consultation with Corbett Lunsford, who runs the Home Performance YouTube channel. He was also a former co-host on a television series that talks about the science behind home building. And we sat down with him, gave him the lay of the land, and he gave us some recommendations. I learned a ton during the 1-hour consultation with him, and I encourage you, if you're going to attempt to build your own home, he's definitely a wealth of knowledge, and it's money well spent to sit down with him and go over your home plans and talk about heating and cooling, ventilation, dehumidification, all the science behind home building and keeping your home healthy and safe for you and your other occupants. So without much further ado, I'm gonna play the highlights behind our 1-hour consultation. At the end, I'll give you my take on the things that I've learned and why we're gonna go in a completely different direction with the HVAC system in this house. So enjoy.
Normally, in this kind of a session where we're kind of trying to plan HVAC and ventilation, I have a protocol that I follow, which is through heating and cooling, and then through the 5 factors of ventilation. But
Sure.
it seems like you have some specific stuff. So why don't you give us kind of like a background on what it is that you're doing and trying to achieve?
So this is a post frame build, which is, I don't know, are you familiar with the post frame construction or? Okay.
Yeah,
So
but
I'm doing this myself. My wife and I have done most of it with the exception of the concrete foundation and the steel roof. Everything else is done by us. So I'm trying to keep it DIY if possible. I know when it comes to HVAC, that can be a little bit difficult. About a year ago, I put in a Mr. Cool mini split in the garage. So we built the garage. I guess it took a year to build the garage. That was my first project, my first ever start from scratch build, and that was post frame. So we did that. We put a Mr. Cool mini split in. I love it, but I have some questions on that. So before we go, we'll chat a little bit about that. And then I've been working on the house for about a year as well. And like I said, I want to try to keep it all DIY, but my specific questions were in climate zone 3, according to the new standards. We went from 4 to 3. And I'm not originally from here, so I know humidity is different from where I'm originally from in Northwest Ohio. So I have a question about wall assemblies and moisture control, ceiling, the soffit vents with a ridge vent that runs the entire length of the ridge. So it's a vented attic. There's going to be no storage up there. I'm not planning on putting any equipment up there. So that's kind of the layout of the build. The wall, since it's post frame, there's like a 5.5-inch cavity in between the posts. Posts are 8 foot on center. So I have a huge cavity in there to fill with insulation. The garage, I kind of experimented with a little bit, and I did open cell spray foam in the garage. I seem to like that, but I don't know if that's the best thing for the house because it's just a little bit different, so to speak. And then the insulation in the attic, I did blown in cellulose in the top, just like 4 inches, just to give me a little something in the ceiling. But I'm thinking about doing the same thing for the house, but I'm open to suggestions with you on that as well. So yeah, insulation, wall assembly, ceiling assembly, air sealing the ceiling. I did for the walls in the house, it's all zip sheathing. All the seams are taped, rolled the tape. All the nail holes are liquid flashed. So I think the outside in the house is pretty tight. The garage was different. We did just OSB and house wrap on that. The windows are vinyl windows. They're Pella 250s. And we can go over the numbers on those if that helps at all. But all those are taped, liquid flashed. I made like a sill pan at the bottom of the window, so it's all liquid flashed around the bottom of the windows. So I think the house is it seems to be pretty airtight wall wise, but where that transition from the wall to the ceiling is, that's my big question. Like, how do I seal that off and get a good air barrier on the ceiling? So those are some of my questions. Mini split versus ducted. If I'm going to be tight, do I need an ERV? Do I go with a whole home dehumidifier with fresh air ventilation? I have tons of questions. I've been living in a camper and an RV for the last 2 years, so I've learned a lot about makeup air and about condensation and what have you. So I don't want to. This is my one chance to get it right. So that's why I'm with you today. I want to get it right the first time and not have issues down the road.
So normally I kind of approach when I think of a home as the skin and then the circulatory systems. So the skin, to get back to your wall and ceiling assembly, I think blown insulation, brilliant. Do you have a raised heel truss?
I do. I did a 15-inch raised heel. Yes.
Oh, great. Nice. Okay, great.
Yeah.
You've got the room for 15 inches. And then because you're zipping and then taping and liquid flashing, I bet you get pretty airtight on the walls. So the question then becomes, why, what does spray foam give you for the extra cost that you wouldn't get else?
I don't know what else would go good in that big open void there, because I don't really want to do like the 16-inch wide bats or the 24-inch wide bats. Is there a product that I could like literally stick in there and cover the whole thing without seams, so to speak?
Yeah, so Bibs is blown in blanket system. Have you heard of that?
Okay. No, I have not.
So you put so I'm going to suggest that on your notes here, that you would have a membrane that you staple to the walls.
Okay.
And then they poke holes in it and just inject this insulation behind it. And so you can do either cellulose or fiberglass in that case. They have different properties. And if you're already using cellulose, then more cellulose is probably fine. There's a training, like I used to give a training on how to do this. So you could do this yourself. But what you want to be careful of is you want to pack it enough so that you don't have it fall. You don't put enough air in that there's air in it, and then in the top it falls over the first. You know what I mean? It actually will probably a lot sooner than that, like in the first couple weeks. So, so you could certainly do that. That would be easier than putting the bats in, because that lattice behind you would be like kind of a pain.
Yeah. The IntelliMembrane, is that a lot? Because in climate zone 3, from what I've seen in an energy code, they don't really recommend a vapor barrier. Is this allowing vapor to move, or what's the intelligence behind it?
A vapor barrier, when you say that to somebody like me, typically means something that stops vapor from moving. And we don't want that, because you have two seasons. So we want the seasons to be respected. If you put plastic on the wall, you're putting it in the wrong place half the time. So I'm going to give you a video on this. What I'd say is that it's intelligent. So it's going to go from, do you know perm ratings?
Yes. Yeah.
Okay. It's between 1 perm and 100 perms. It varies based on how pressure of vapor there is pressing on it. If a lot of vapor is trying to go through it, it'll be like, okay, go ahead. But it just kind of regulates. It's like an ERV in that way. It's a buffer.
Okay.
It just slows everything down and just is like, all right, let's have a reasonable, consistent flow of things in and out of the house. So that way you're protected against that kind of issue.
Gotcha. Okay.
Your windows sound great. Your ceiling sounds great. That's all in it, like as inexpensive as you can get it to be. So do that, because that's like you're doing the DIY thing well there. So the air tightness is achieved by zip, and then you're doing air sealing of the ceiling.
Well, I would like to. I don't know how to. That's the thing. Do I do like a Myrex paper on the top? What do you recommend for that?
That's basically the same kind of an approach as the Intello. So you could use the Intello there if you wanted to, which is I have in that video that I'm giving you. So behind you, at the top of this wall, what do you have at the at the top there to air seal. Is there a block? It looks like there is. Is it a fire block?
There is. It is. It's 5/8 drywall. Yeah, that was so the framing, the trusses all sit on they're either 2x10s or 2x12s because I have a timber frame porch on the other side. You're seeing a 2x12 there, but that's open in between there. So that whole wall cavity goes up. So to fire block, I put 5/8 drywall in there to meet code. And then of course I have to, any wiring or anything that I run through there, I'll have to, air seal. But yeah, that's exactly what I did there.
And then you're going to dump that box, that trough will hold cellulose, right? So you're going to put cellulose in there.
Yep, that is correct. Yep.
Great. So heating and cooling, how many square feet are we talking about here, Brian?
It's 56 by 40. So like 22 something, 2240, 2250.
Is that outside?
That's outside. Yeah.
Okay.
And the blueprints I sent you, I think it shows 12-foot ceilings. We're only I went 10 foot on the ceiling. So we're 2 foot lower.
All right. So 22,400 cubic feet of air. So then do you have a air tightness target in mind?
I don't. And that's part of the deal with this call, is trying to figure that out. I mean, I want it to be tight. I don't need to be like, what do they call it when you're like super tight? Like
passiveness.
Yeah.
Okay. So 2 questions. One is, you've already answered. Do you have a means to get extreme air tightness? And you do. You're using zip, you're using air sealing, you're potentially going to use this interior membrane, like the Myrex or the Intello. And then the second question is, are you committed to using an ERV to exhaust out of your bathrooms?
I am. So here's the deal with that. The name is escaping me. What's the Cadillac of ERVs? The brand? Zender. Yeah. So I called them, I sent them my blueprints, and they sent me back where they recommend to put the inlets and outlets. And I seen the price and I was like, whoa, that's a lot of money. But I love the idea of it. I love not having bath exhaust fans. But what worries me, here's what worries me with the ERVs. It doesn't have any dehumidification properties, right, with the air that it's bringing in. So I would be dumping very humid, like today, very humid air inside the house. Is that the best thing to do?
So to clarify, it's not a dehumidifier. It will net today. If you had it running, it would have a net humidifying effect. But an HRV just dumps raw humidity inside your house. And ERV actually is about half of the humidity out. So it'll like, because essentially what the second question is designed to do is to get you to tell me whether you're ready to go gangbusters on air sealing. Because the worry is, and I'll show you here in a calculator, we're going to go like this. All right. So if your house is 22,400 and you get down to 1.5 ACH 50, that is divided by 60 times 1.5, 560 CFM 50. So if that's our floor door number, and then you turn on a dryer, a normal vented dryer in the house, it'll depressurize the whole house to 7 pascals. That is not a great idea. Do you have any fireplaces in the house?
No. So this was a discussion between my wife and I. I was like, hey, if we want a fireplace, let's put it outside. Because they're just energy. They just suck the energy out of the house. We've owned some older homes that had true wood burning fireplaces, and it's like, this is a waste. You're blowing the heat out the stack and you're sucking in all that cold air into the house. It's just, I don't like it. And I'm glad you mentioned the dryer. I forgot to tell you, I'm going ventless on that because again, you're poking a hole in that outer membrane, and like you said, you're just creating a huge waste of energy. So I want to do the new style dryers that they have, the ventless with the condenser and stuff inside the dryer.
Awesome. The heat pump?
Yeah.
Great. Okay. So aside from the dryer and the fireplace, one bath fan, if you turned on a 50 CFM bath fan,
Okay.
All the size you can get, it would depressurize the whole house to 1.4 pascals. That's not the end of the world, but if we turn on 2 bath fans, because you have 2 bathrooms, right?
Yep.
Now it triples. So now we're at 3.8. That is enough pressure to backdraft a chimney. Thank goodness you don't have one inside. It's enough
Yeah.
pressure to backdraft a atmospheric draft water heater, which you're also not going to have, I'm assuming.
Yeah.
Um, so you can imagine how much that is, and that might start to do weird things because as far as the air tightness goes, what we want to have happen is all of the air leakage is diffused across the entire house. So any gaps and cracks that are going to bring in air are set, they're like spread out. If,
Yeah.
God forbid, you have a lot of them in one place, or we have a continuous influx of air, like in Florida, that would be a disaster for mold. Where we're at
Yeah.
half the year, it would be a disaster for mold. And so
Right.
that it's important to remember that kind of stuff. So I would say that if you are committed to, if you have the means for air tightness and you're committed to using an ERV to exhaust from
Yeah.
bathrooms, then great, shoot the moon on the air tightness. Because once you get to 3 ACH 50 on the blower door, you're kind of future proofing the home against energy codes. So you'll never
Okay.
have tighter than that. It'll meet energy code forever. And you're getting a lot of the benefit of the sizing for your HVAC uh, being brought down for energy bills, stuff like that. But once you go past 3, what you're getting is no bugs, very little noise from outside, extreme humidity control and comfort, and you know exactly where all your air is coming from. So it's worth it if you're going to commit to that ERV balanced ventilation thing. Then just like air seal the crap out of it. If you're not going to, then do not air seal the crap out of your house. Like stop at some
Yeah.
point. Like you don't want to get to the point where you get tighter than this. We get down to 1 ACH 50 on this accidentally, which is 373. And now one single bath fan is going to depressurize the house. And
Wow.
like that's a lot. And then
Yeah.
your kitchen exhaust hood, if you put in a 400 CFM kitchen exhaust hood, code says you don't
Yeah.
need makeup there. That's more than a blower to test.
Oh,
So this is
wow.
the calculus that you want to use there. Okay, so for circulation, so let's just do your heating and cooling load. Have you already sized this? Have you already thought about how big your air conditioner is going to need to be?
Yeah, well, I did a manual J very
You did?
early on. Yes, I had a company. I think I sent them the blueprints and there were some changes on it. And I kind of told them like, hey, this side of the house is facing this direction and all that good stuff, windows, doors. We've had some changes since then, so I don't think it's probably as accurate. But that was for using mini splits as well. So,
Okay.
but yes, I have done a manual J.
Okay, great. So was it somewhere between 3/4 tons and 2 tons for the whole house?
That sounds right. I don't know. Actually, I think I still have it.
So let's look at this real quick. Here, I'm gonna flash I'm gonna put your house up on screen. Okay, so here's
Yeah.
elevation. Nice
Yep.
compact little. All right, and then here we've got this. So the garage is its own thing. We won't worry about that. We have a head here. Did you put a head in the bedrooms as well?
I have not done so. So
Oh,
that's my
I know. I'm
question.
sorry. In the design, is that how they?
Uh, I planned. Yes, I did plan for it.
Okay, so that's 4 heads. The smallest head size you can get is half ton. So that means
Okay.
that you're already oversized by just adding the heads. Also, there's no way for air to circulate between, like you said, in the garage. It's not enough
Yeah.
to. So the den won't get any air unless we force it. The walk-in closet, the laundry slash pantry won't get any air unless we force it. And so those are called transfer fans. So for
Okay.
example, in the that I'm in right now, I
Hmm.
have a ductless mini split that's up on the wall for heating and cooling. But in the crawl space, I have 3 duct systems because going ductless on the heating and cooling doesn't really solve the problem because we still have to do the 5 factors. So circulation, mini splits don't do it. Within
Yeah.
rooms, but not between rooms. Capture and filtration, they have terrible filters in them.
Yes.
Humidity control, they're not going to do a great job with humidity control, as you already probably figured
Yep.
out. And then dilution air, obviously they're not doing, and pressure relief. So we don't have a
Right.
way of getting pressure relief kind of ducted around the house if we wanted to, which normally I don't recommend that anyway. So mini splits don't really solve many of these. They're kind of doing the heating and cooling, which is outside this calculation. So
Yeah.
having a duct system, I think, would be a good idea. But the question is now, where in the world are you going to put this duct system?
So we changed the framing up a little bit. So where that back door, where the side door comes in from the garage,
Okay.
just below that, there's probably, I'm going to call it a 8 by 5 foot room in there that we took it out. We actually moved the walk-in closet. So the den is actually a walk-in closet. And then across in that great room, the room that I'm in right now, in front
Mhm.
of that window there is another room that looks just like the den that we're going to use as the den slash office area. So
Like
my
here,
main
kind of, is
power,
that what you mean?
other end,
Oh, I'm
front of
sorry.
the house.
Oh, okay, yeah, got it. So
Yep,
this.
yep, yep.
Okay.
Exactly. So that's the way the house is laid out. And then the walk-in closet, the left side of it, just below that walk-in door, there's an area for, because I was planning on an HRV or an ERV or something to go in there. So I have enough room where I could put a ducted system in there if I wanted to.
Okay. And how would you get it across the great room? Are you going to drop the ceiling, or are we going up into the attic?
No, I'm actually on a crawl space.
Nice.
Yeah,
Perfect.
so I did post frame on a crawl space. It's unvented. It's solid concrete with a reverse brick ledge and 2 by 10 floor joists. So I have um it's over 2 feet of space in between the floor joists and I did a vapor barrier in there. I did the Stego Industries system
Great. Okay.
down there.
Yep.
So yeah, and that's another question I have for you is what is the best way to take care of the humidity that's down there, of course.
Okay.
But yeah, so I could run all the duct underneath, all the duct
Awesome.
work.
Okay, great. Well, let's look first at this. So we're going to do that right there. This is a 15 CFM. Oops, I'm sorry. I'm editing the crap out of your little drawing. 15 there. We get the shower here, which is separate from this toilet because of that wall. So we're going to want this here. That's going to be 25. So we're already up to 40. And we've got this bathroom over here. Is this also a full height wall, or is this a pony wall?
That'd be a full height wall.
Okay. If you said that here's the issue. We're sizing the ventilation two different ways, one on exhaust and one on supply. Your master
Okay.
suite already separated across, so you got a separate powder from the shower. So 40, they assumed 35 in their manual J. We're already past that, and we haven't even done the second bathroom yet. So I'm worried that we're
Dang.
going to overshoot the amount of fresh air you need by requiring that the ventilation be different. So here's the deal. If we put this exhaust here in the shower, it's not going to
Yeah.
grab odors here. The odors in this toilet area would be able to wander all our way around the house, not around the house, but around the room, and
Yeah.
like it's gross to say it, but soak into the materials.
Yeah. Yeah.
So we don't really want that. So I would recommend, if you're going to keep it this layout, you've already done the plumbing here.
Nope, have not.
Oh, okay, great. If you could just swap these,
Okay.
then you could put this in the shower, and the air will come in under the door and make a beeline for the shower, and it'll grab, like, sort of more than it is
Yeah.
now. It'll grab the odors from the toilet before it gets a chance to go to the other side of the room, at least.
Gotcha. Okay.
So if you could do that, then that'd be cool. What we'll do right now is just put it like right. We'll do one here. Wait, then that's not good. I normally don't like that.
Yeah. Yeah.
We'll do 5. Okay, so now
Because it's
we've
going to suck from the underneath the door, right? And not actually pull. If you put it in that location, it wouldn't actually pull from the shower or from the toilet. It's taking the easiest path, which would be through the doorway, right?
exactly. And so it's like,
Yeah.
yeah, but both in this scenario now, both the steam from the shower and the odors from the toilet are kind of allowed to wander around a little bit, which is why I
Yeah.
guess. So again, not ideal, but let's not add another one there. So we've got 65
Okay.
CFM here. So our capture is 65 CFM. And you don't have any rooms that are loadless, which is good. Like, all these rooms have a load, this exterior wall, this exterior wall, this
Oh,
wall.
yeah.
So all of them need heating and cooling. So there's often people will define this big, nasty, not nasty, beautiful, giant floor plan. And then there's a bunch of rooms in the middle that aren't going to get any heating or cooling. Okay. So kitchen hood, what are you cooking with?
It's going to be electric. Yeah, it'll be electric. We're going to have no gas in the house.
Okay. assuming 400 CFM exhaust
Okay.
for now. All right, and then radon. Are you doing a radon? Did you already do a radon system of some kind?
No, I did not. What I did is I put a vent underneath the vapor barrier the stego system that I put in the crawl. It's vented actually outdoors, but I don't have any kind of fan on it at all, if that makes any sense.
Vented outdoors how? Through PVC?
Yes. Yep. It's
Awesome,
a
good.
it's a it's a hole in the concrete. It was actually a drain, supposed to be a drain underneath there, but I just put the vapor barrier right over it.
Great.
So it's
Monos,
no pressure buildup underneath there.
great. Air things sensor. Those are like, $200. What this says is your whole house needs 97 CFM every minute of every day. Oh, very interesting. But we can get 13 and a half for free from air leakage. So actually 80. That's really interesting. Actually, what that says is
Huh.
your like it's a very simple shaped house, which makes
Yeah,
it complex than I think it actually is. So that means we've got room. If we wanted to match the fresh air needed and the exhaust needed, you don't need to move that bathroom around at all. You just have two. So we're going to move this one back down here. And then
so
we can
this would create a neutral pressure differential between outside and inside.
no, yes, it will, but we would do that anyway. What we normally do is pick whichever one of those numbers is bigger. And often
Okay.
there's discrepancy. So it's like, oh, well, we need way more fresh air than you've got bathrooms. Or from a lot of my clients, they design a bathroom on every single bedroom. And then it's like, you need twice as much exhaust as you need fresh air. And there's nothing to be done about it because you designed it in. In your case, the fact that we can match it perfectly means we pick either of those numbers, which is 80, and
Nice.
use that.
Sweet. So I got lucky for once.
Yeah, right. Sure did. These are called Fantech MGE. So exhaust is the E. S is a supply side, but you won't need that because you're probably going to plug it in anything. You damper it with this little screw on it. So you can
Oh,
just
cool.
down as you need. And then you can kind of balance the bathrooms because you're going to want 15 out of that shower, or excuse me, 15 out of the toilet. Partly because this room is tiny, 3.5 feet by like 5 feet or something like that.
Yeah.
No, by 7. So that's, 210 cubic feet divided by 60 is like 4 CFM. You take 4 CFM out of that bathroom, you're getting one complete air change per hour. We're doing 15. So every 15 minutes, that powder room in the master is getting completely exchanged
Wow.
air. Shop for a Brone 1, 150 CFM, or Brone AI. And this is where it gets weird. I'm going to recommend a 210 for you. I'm about to
Okay.
install one of these myself because what you're going to do is run it down at a much lower speed. So it's rated at like 75% efficiency for temperature and about 60 for humidity like where it's supposed to be, but you're going to run it way down, which means you're going to up the efficiency and it makes it a lot quieter. Any of these ERVs you run them up toward their top speed and it's going to get a little bit loud. I would recommend the Brone 1, which looks like this. It's new. This thing I haven't been able to recommend it very often because
Now, is this a self-balancing system or do I need to have someone
yes,
come in and balance it?
this has the AI on it. It's
Okay.
just it's easier because this one smartly they put both of the outside things on one side. And you tell
Ah,
like you put it on the wall and you're like, okay, outside is that way. So I want you to run it, in this direction. Or outside is that way. You just flip a switch and it's like, oh, great, no problem. And it'll do what you want it to do. So the other ones, the AI is not designed like that's a drawback of them is that it's like one outside here and one outside here, and then it's crazy.
yeah. Okay.
Don't put them really close to each other. Um, put intake and exhaust at least 10 feet apart. So if you follow this thing, this is the layout that'll work most of the time. This is kind of what I'd recommend for you. Again, if you went with the ductless mini splits, what you'd need is still the ERV. You'd still need dehumidification. You may
Yeah.
find that you need humidification because what's going to happen, you have a 373 one air change per hour rate. So if we took 373 CFM every minute of an hour out of the house, we would have replaced all the air in the house. So we divide that by 84 and we get 4.5 hours. So every 4.5 hours, all the air in your house will be made fresh.
Wow.
At the,
Okay.
so we don't want more than that. And what you might find is that like it dries out when it gets cold down at the 20 degree level. It's going to be like 30% or even less than that. And I find that my wife will get nosebleeds sometimes, and that's not pleasant, but like
Yep.
wouldn't necessarily recommend the humidification, but if you had to, you can do it with this duct system. Okay, so let's now look at your humidity control. Humidity control. All right, so what this calculation says is we're going to take the grains per pound that we need removed, which is we need to bring your 133 on your peak humidity day down to 65. So we're going to take 68 grains per pound out. We know we're going to be running at 84 CFM of fresh air coming in, times the little coefficient here, which is 0.0148. Sorry, 68 times 85 pints per day. But the ERV will strip half of that automatically. So really you're
Okay.
looking at 42 pints per day. Okay, so that doesn't mean that we shop for a 42 pint per day dehumidifier because a 70 does 55 at the actual conditions you're going to keep your house at. So I think that 55 or a 70 pint per day would be fine. And this Santa Fe has a 5-year parts warranty, 6-year, or excuse me, 5-year replacement warranty, 6-year parts warranty. So like they're kind of leading it right now, and they also make really good high efficiency stuff. And then pressure relief. Let's just do that real quick.
Sure.
Okay, so 400 CFM we know might be more than your blower door test if you actually take your house to where we think that it might go. So let's just real quick do this passive. There's 2 ways to make up air. One is passive and one is active. The passive way is not as good because you're only going to be able to relieve the pressure down to 2 pascals. So there have to be some depressurization a little bit because the way that it works is by tilting the house basically. And so if the airflow, if the pressure disappears, the airflow disappears because that's just how airflow works.
Sure.
So 400, we're going to duct it with 8-inch round. Is it going straight out through the wall, Brian?
It would probably, I mean, it could, whatever is best. I
Oh,
could
okay.
take it up and out. Yeah.
Yeah, up and out I think is better. So here and a little bit bigger would be a good idea.
Okay.
Uh, like 6 inches, 12 inches would be even better. Make it kind of like an inverted bathtub over the top of it. And
Gotcha.
we're going to go like this. It's going to be 5 to 10 feet probably. So we're going to get 430 out of it. We want to depressurize as little as 2 pascals. We got 2250. We got a ceiling height of 10. We're going to build. I'm going to be conservative here and say that you might hit 1 ACH 50, which is totally
Okay.
possible. I was aiming for 1 and I hit 0.4.
Wow.
So knowing what little I know about you, I think that you're a detail oriented person and you could totally overshoot. And that happens with builders all the time, like who aren't even
Okay.
trying. Accidentally, oops, we built
Yeah.
really. All right. And then this will make, yeah, I think we'll make it the same length as that. The idea here is if you can bring in the fresh air, like uh, let me think about this. Yeah, in the ceiling could work, but if you brought it in here and here, then it kind of makes this pincer move on the cooking fumes
Yeah.
and pushes them against the wall and then takes them outside. At the very least, make sure that you put it centered on this so that it goes in and traps it against the wall. If you put it all over here instead, then it would
Yeah.
shove this stuff out into the room.
Gotcha. And again, that's not an ERV vent
This is
there.
Yeah, this is just a hole in the wall.
Yeah. Okay.
This is the makeup air. So in order to passively pressure relieve your home, which again, I already said is like not as good because we're going to all be a little bit depressurized. And it's not as good because you need a lot of holes. You're going to need 5 8-inch holes in the wall and 1 6-inch hole in the wall. or
Wow.
we can have 3 10-inch holes and 1 8-inch hole. Do you want to do any of that?
Do I want to do any of it? I mean, it sounds bad.
Sounds really bad. Yeah, right. So I'm going to print
Yeah.
this out for you, and this is what you look at when you say, "Why am I spending $2,500 on makeup air system?" Um, because the real thing to do is use the active system.
Let's talk about the crawl space. What is the best thing to do underneath there? Just put a dehumidifier, or should I make it kind of an air plume and or plenum and tie it in with the rest of the house? What do you recommend?
I would tie it in with the rest of the
Yeah.
house. We could it's like, so I come at this thinking about HVAC as an enclosure guy. I was a HERS rater first. So I was always looking at insulation and air sealing. And what I learned about those is you always want everything to be either completely an inside space or completely an outside space. If it's kind of inside, kind of outside, or if
Yeah.
it's inside, but you act like it's outside, or if it's outside and you act like it's inside, then it's problems. So, and mostly for condensation. So I'd say in your crawl spaces case, like the HVAC guys will be like, well, how are you going to guarantee what temperature and humidity it's going to be down there? And you would say, that's your job. Like I'm asking you to make that space exactly the temperature and humidity as in the rest of the house. That is what
Okay.
HVAC is. So that's really how we do it is we force it to be the same temperature and humidity as the rest of the house. Any last questions or comments?
I am I'm excited to get started on this, and I'm so glad we had this conference. I keep telling people on the channel, like, it's not rocket science to build a house, but there's definitely science involved. So,
Right.
and this is one area you have to get it right, otherwise you're really going to run into big problems down the road. So I'm so glad I did this. Thank you so much.
Awesome, man. Thank you very much, Brian. So, and you guys can tune in to Brian's channel at, is it NC Barndo?
Build. Yep. NC Barndo build.
Okay, great. And I'm linking that below as well. So good luck
Perfect.
with the rest of the thing. I'm here if you need me, but you get your head on straight about this. So I'm excited to hear back that you moved in and everything is perfect.
Yeah. Thank you so much.
All right, later, Brian.
Hey, see ya. Wow, lots of good information, things to chew on, and things to consider for home performance. For us, I think moving from the mini splits to a centralized unit is going to be a better option the way we're set up. However, I think we're going to have to redo some things or rethink some things at least with going with that type of system. So it's going to be interesting moving forward. This is by no means the end to solving this problem or coming up with a good solution for a nice, healthy home for my wife and I. So stay tuned. We'll see what happens here. We're definitely going to pivot and move in a different direction with the HVAC, ventilation, dehumidification side of things. So yeah, hopefully you stay tuned, see how we deal with all that, and hopefully come up with a great solution for our home. Thanks for watching. We'll see you guys on the next video.